Hello, dear students. I hope you are enjoying the learning with PChem Easy by Dr. Barman. So today we will talk about the stereochemistry of beta-lactamase inhibitors. In the previous lecture of stereochemistry, we discussed about the stereochemistry of penicillin's derivative. So in penicillin's derivative, all the penicillin derivative will have the common stereo center. So the configuration in all the penicillin derivative will remain same. Here today we will talk about the stereochemistry of beta-lactamase inhibitor because the beta-lactamase inhibitor it can be vary. Okay, so there are different examples of that beta-lactamase inhibitor like Sulbactam, Clavulanic acid, then Tazobactam. So today we will talk about the stereochemistry of Clavulanic acid, then Sulbactam, followed by Tazobactam. So now we'll talk about Clavulanic acid. This was the stereochemistry of all the penicillin derivative. Already we have discussed here. So in the penicillin derivative, C2 configuration or configuration of C2 carbon will be S, C5, C6 will be RR. Okay. So now the clavulanic acid, as you can see, what is the clavulanic acid? Clavulanic acid is an beta-lactamase inhibitor. Okay. So beta-lactamase inhibitor, but isolated from Streptomyces clavulgaris. Okay, so this is the species, or you may get the question. See, when you will see this clavulgaris, so definitely you will understand that it is isolated from the clavulgaris. But in the exam, you will get the question from this part. It can be Streptomyces clavulgaris, Bacillus clavulgaris, or Staphylococcus clavulgaris. Okay, so you will have to remind this part, Streptomyces clavulgaris, right? Second one, clavulanic acid. It is structurally oxopinam. Okay, so as we have seen the pinam, so pinam ring will have this beta lactam plus this sulfur. Okay, this is called the pinam ring. Here the sulfur is replaced by the oxygen. Okay, so that's why it is called the oxopinam derivative. Lacking 6-acyl amino side chain of penicillin C. Here we will not have, or this structure will not have 6 amino derivative. Okay, so it is different in that context also, but also have 2 hydroxyethylidene moiety at third position. 1, 2, 3. So this is 2, 2, 1 and 2 hydroxy ethyl 1, 2, but it is having the exo bond with this cyclic compound, so it would be ethylidene. Okay, so 2 hydroxyethylidene moiety at 3 position. Now, so this is the IUPAC name, how we can do the nomenclature of this compound. Okay, so here it is written with fire, so it will be oxa, 4 oxa. Okay, 4 oxa, 1 as a bicyclo, 3,2,0 heptane 2 carboxylic acid. See, this is the bicyclic compound. In that bicyclic compound, the nitrogen and sulfur is replaces the carbon. Okay, so bicyclo compound, this is the 4 member, this is the 5 member. So in the bicyclo, we have to move towards the bigger ring. So numbering will start from here. Then this will get position 2, 3, 4, 5, 6, 7. Okay. So now we will talk about the stereochemistry of this structure. This is the structure of clavulanic acid. As you can see, it is not having any amino group. Everything is similar as compared to penicillin. Just the difference is it is having oxygen and this group. This was also present in penicillin. So now we will see, as we can see here, there are two position having the stereo carbon or stereo center or chiral carbon. Okay, so or asymmetric carbon. So now we will have to assign the configuration at C2 position and this C5 position. So what we will have to do, see this, we have to find four different groups. So as you can see, this is the carbon bonded with here nitrogen, here hydrogen, here this carboxylic group, here carbon. Okay, so now what we will do, we will have to assign the priority. So as per atomic number, this nitrogen will get priority first. I told whenever you see the hydrogen, give it 4. Now see this. Now we will have to compare this carbon and this carbon. So if we talk about this is the carbon. Next attached group is oxygen here and here it is carbon. So carbon carbon double bond. So if we will open, see suppose this is the chiral center. Just I have expanded this portion. So this is the carbon, this one, and it is having the carboxylic group. So carboxylic group, this double bond, it can be assumed like C single bond O, C single bond O, and here it is having the oxygen and hydrogen. See this. Then here it is also having the double bond, so double bond carbon, double bond carbon. So it will be assumed like this carbon is bonded with two single bond carbon. So we will assume like that. Now what we will have to do, we will have to see the point of difference. So now we will compare that. Here this is the carbon bonded with oxygen and carbon. What about here? This is the carbon bonded with oxygen to oxygen. Here carbon. Okay, so this is similar here also, and this is also similar with this carbon. But what about this? Here it is bonded with carbon, here it is bonded with oxygen. So this group will get priority over this one. So this will get 2, this group will get 3. So now 1 to 2 to 3, we have to move the anti-clockwise direction. As you can see the arrow, this is the anti-clockwise direction. So as per the rule, if it is anti-clockwise direction, it means it would be S. But see the lowest priority group, it is in wedge bond, it must be in dash bond. So what we will have to do, if it is S, we will have to revert it. See this, it is R configuration. So this was the configuration about C2 position or carbon number 2 position. Now we will talk about the another stereocenter or another chiral carbon in this clavulanic acid structure. So that is the in this position, that is the C5 position. So what we will do here, again we will have to find the four different groups. As we can see here, it is bonded with oxygen, here bonded with nitrogen, and here it is bonded with carbon, and here it is bonded with hydrogen. So what we will have to do now, we will have to assign the priority. Oxygen will get first priority because it is having the atomic number 8. Nitrogen second, 7, carbon 6. So it will get the priority 3. And the hydrogen, as I told you, whenever you see the hydrogen, just give it 4. Now we will have to move 1 to 2, 2 to 3. See, this is the clockwise direction. And what about the least priority group, that is the hydrogen? It is in dash bond. So what we will have to do? Nothing to do. As it is the clockwise direction, just we will have to write it is R. So here you can see the C5 or 5 carbon at 5th position, it is having the configuration R. Okay, so this was the stereochemistry of clavulanic acid. Now we will talk about the second beta-lactamase inhibitor, that is sulbactam. So as you can see the structure of sulbactam. What is sulbactam? Sulbactam, if you see that the name indicating bactam, it is having the beta lactam ring, but sul, okay, sul means sulfone group is there. Okay, see, if you remind the structure of penicillinic acid, okay, so everything is just a structure of penicillinic acid exception these two double bond. Okay, so in that sulbactam, this sulfur is converted into or oxidized into the SO2 group. So that is called the sulfone. So this sul and bactam. So this is the structure of sulbactam. Now we will have to assign the configuration. So as you can see here, there are two chiral carbon. First one at C2 position and another one is here, that is the C5 position. So what would be the configuration of that compound, that carbon? We will see here. So this is the chiral carbon. Now we will have to assign, first we will have to find the 4 different groups, then we will assign the numbering or priority. So you can see here, first group or group 1, group 2, group 3, group 4, but we have to assign the priority. Here it is bonded with nitrogen, here it is bonded with carbon, here it is bonded with carbon, and here it is bonded with hydrogen. So carbon-carbon will get the priority later on. First it is bonded with the nitrogen, so that nitrogen will get the priority first, that is the 1 priority. Then after that, hydrogen it is having, give it 4. Uh, now we will have to compare this one and this one. So now we will see, this is the carbon, here it is bonded with carbon, here also it is bonded with carbon. Now no difference, but now what we will have to see, as per the second rule of that preference or priority rule or sequence rule, we will have to move towards the next atom which is directly attached to the this particular or that common atom. So here it is attached with the sulfur, sulfur having the atomic number 16. Here it is attached with the carbon, that carbon, here it is attached, yes, here it is attached with the carbon, carbon having the atomic number 6. So 16 will get preference over that 6. So this will get the priority 2 and this will get the priority 3. 1 and 4 already we have assigned. So now 1 to 2, 2 to 3. Okay, so as we are moving towards the uh, clockwise direction, see, this is the clockwise direction. So but here as we can see, if it is clockwise direction it will be up. I'm talking about the C2 position. So this is the C2 position, this is the C2 position. The configuration will be R, but what is that? It is the least priority group, hydrogen. It is in wedge bond, it must be in dash bond, so we will not change anything. But as it is in wedge bond, we have to revert the stereochemistry. So here we will have to revert the configuration. See, this is R, so we will write it as. Now this was the stereochemistry of C2 position or configuration of C2 position. Now we will talk about the configuration about C5 position. So now see this, this is the C5 position. See the 4 different group. 1, this is 2, this is directly attached to that carbon. 1 group, here carbon attached, here sulfur attached. Okay, so here hydrogen attached. So what we will have to do, we will have to assign the priority. So here it is having the sulfur, so obviously this will get the first priority, then nitrogen because of the 7 atomic number, then carbon having atomic number 6, and in the last 4 hydrogen. Now we have to move 1 to 2, 2 to 3. So it is a clockwise direction, and see the fourth one group or the least priority group, it is in dash bond, so nothing to do. If it is R, we will write it R. That's it. Okay, so this was the stereochemistry at C5 position. Now, the important point here, sulbactam is a penicillinic acid sulfone. This is the sulfone. If you remove these two double bond, it will be penicillinic acid, but it is a sulfone derivative. Okay, you can also write 4,4-dioxopenicillinic acid. 1, 2, 3, 4. So 4 position sulfur having 2 ketone groups, so 4,4-dioxopenicillinic acid. Potent beta-lactamase inhibitor, less antibacterial activity. Okay, so these beta-lactamase inhibitor, they doesn't have any, see, beta-lactamase inhibitor example, but they have less antibacterial activity. So why we are giving this? We have to give this in the combination of in the combination with amoxicillin or any penicillin derivative, because that penicillin derivative, it can degrade it by beta lactamase enzyme, so we have to inhibit that particular enzyme. So that's why we will give these medicine in a combination with amoxicillin, ampicillin. Okay, so that's I hope you have already seen that amoxiclair, amoxiclair. Clav. Okay, so here it is having the clavulanic acid and amoxicillin. This is the combination. So this was the stereochemistry of Sulbactam. Now we will talk about the stereochemistry of Tazobactam. So let me draw the structure of the Tazobactam. Tazobactam. So the name itself, it will tell you why it is Tazobactam. So now it will have the beta-lactam ring, as we can see here. This is the beta-lactam ring. The difference, the Tazobactam will have the C. It is a derivative of Sulbactam. So everything will remain same in that Sulbactam. This is the Sulbactam, and here, in case of the Sulbactam, it was having that the methyl group, two methyl group. So here, one methyl group will be replaced by, you can say that C. Let me draw first, then we will explain. This is the group called triazole. Triazole. Three nitrogen, tri as a and ol. So five-membered ring having three nitrogens. So triazole. See, what is this? This is the CS2. CH. So it was the derivative. Here it was the CS3, two CS3. Out of that two CS3, one CS3 or hydrogen of one CS3 replaced by this triazole group, and here it will remain same as we have seen in case of the, it will be also in the gas bond, and here the hydrogen will be in red. Now this is the structure of Tazobactam. Here this is the position also having the stereo center, and this will be CH2. So this is the structure of Tazobactam. Now we will try to assign the configuration. Okay, so we'll talk about how we will assign the configuration. So as you can see here, there are four different groups, and in three carbon. Also, there are three chiral center. So we will have to talk about each. So how we will draw that? How we will assign the configuration of all three carbon. So first we will talk about the carbon at C2 position. C2, okay, or C2 carbon, or carbon number at 2 position. See the four different groups. First, hydrogen, nitrogen. Whenever you see the hydrogen, give it 4. Nitrogen, carbon, carbon. So nitrogen is there. Obviously, it will get the priority first. 1. Now these two carbon. Okay. So here, this is bonded with the carbon. Carbon to carbon means this is one group. This is another group with this carbon. So here, see, this is the carbon directly bonded with sulfur here, and here carbon, here also carbon. What about here? This is the group carbon, two oxygen and one more oxygen here. So it is basically this carbon having the three oxygen with single one. Two will be here as it is double one, and one here. But here it is directly attached with the sulfur. So sulfur having the atomic number 16, so it will get the priority. So this will be 2, this will be the 3. Now we will have to move 1 to 2, 2 to 3, 3 to 4. So it is clockwise direction. But what about this? If it is clockwise direction, it must be R. But the least priority group, that is the hydrogen, is in wedge bond. So we will have to revert the stereochemistry. We will have to revert the stereo center. We will have to revert the configuration. So if it is R, we will have to write S. In exam, if it is asked the configuration of C2 position in Tazobactam, it would be S. You have to remind the structure and you have to find out the configuration. Okay, then this is the carbon number 1. It is done. Now we will have to talk about the second carbon, that is the at C3 position. So we will give the C3. What about that? We will have to find. So this is the chiral carbon having three different groups. One is sulfur, rest three is, see, this is the group attached here, this is the group attached here, this is the carbon, this is also the carbon. Now we will have to find, we will have to assign the priority. So now we will do this one. See, as it is having the sulfur, it will get priority 1. Now we will have to identify these three. So now we will have to look. See, this is the carbon directly attached here. So this is the carbon. It is bonded with nitrogen. It is bonded with carbon. It is bonded with hydrogen. Okay, compare here. This is the carbon and this is the carbon, next group. So you compare with this. This is the carbon. It is bonded with 2 hydrogen and 1 nitrogen. See, you compare, if we compare this carbon with this carbon, here, yes, this is the carbon which is bonded with nitrogen. Here, this is the carbon which is bonded with nitrogen. That is offered, that is the similar one. What is the difference? Here, this is the carbon having hydrogen. This is carbon having one also hydrogen. One hydrogen is also there. Now, this is the carbon which is bonded with hydrogen, and here this is the carbon bonded with carbon. So this is the point of difference. Okay, so obviously this was the first one, so this will get priority 2. Now we will have to compare these one. So as we can see here, the carbon having 3 hydrogen, but here carbon having nitrogen, 2 hydrogen. So this will get priority 3, and this obviously it will get the priority 4. The least priority group, see, CS3, it is least as compared to this one, and this one. So now we will have to move 1 to 2, 2 to 3, 3 to 4. So 1 to 2, 2 to 3. Okay. So now it is anti-clockwise direction. Anti-clockwise direction. So what it would be? It would be S. C3 would be S, and C, the least priority group, it is in dash bond. So nothing to do. It will remain S only. So now C2 and C3 position will be in S configuration. Now we will talk about this carbon. Okay, so now let me change the ink so you will not get confused. See, the carbon, chiral carbon, 4 different groups. Here nitrogen, here sulfur, here carbon, here hydrogen. Obviously it is having the sulfur, so it will get the priority 1. This is nitrogen 2, this is 3, and this is 4. 1 to 2, 2 to 3, 3 to 4. 1, 2, 3, 4. And the least priority group is in dash bond. So what we have to do? C5 configuration here, 1 to 2, 2 to 3, it is the clockwise. And as we can see here, if it is clockwise, it will be R. Okay. So the least priority group is in dash bond. So nothing to do. It will remain as such. The R, it will remain R only. So in case of Tazobactam, the configuration of C2, C3 and C5 position, it would be SRR. That's it. So this was all about the stereochemistry of beta-lactamase inhibitor derivative. I hope uh, you are enjoying the learning with PChem Easy by Dr. Barman. So now you also like, share and subscribe so other students can also get benefit about this.